So, welcome to lecture number 44 of fuzzy sets, logic and systems and applications. In this lecture, we will discuss the dilation of fuzzy set and composite linguistic terms, and also we will discuss some of the examples. So, let us first take the dilation of any fuzzy set. So, as we already know that any linguistic value is always represented by a suitable fuzzy set. So, let us say if we have a linguistic value which is represented by a fuzzy set A, and we are interested in the dilation of this fuzzy set. So, the dilation basically here is expressed by, or I would say the represented by DIL. So, dilation in short symbolically represented by DIL, and if the fuzzy set A which is being dilated is represented by DIL of A. So, dilation of any fuzzy set here is DIL of A, and this is represented by here is equal to A raised to the power k within bracket equal to, if it is a continuous fuzzy set, we use the integration sign and then we write the universe of discourse capital X, and then we write mu A of x raised to the power k oblique x. So, what we are doing here in dilation of any fuzzy set is we are basically taking we are raising the power of the membership function, but this here this raise of k is the opposite, and in other words we can say we are decreasing the power. So, here mu of A raised to the mu of A of x raised to the power k oblique x, and here please understand that this k is always less than 1. So, the value of k here is for dilation is always less than 1, and similarly here if we have any discrete fuzzy set, A, so on the same lines we go for dilation, and here also we write DIL of A which is equal to A raised to the power k within bracket equal to summation over universe of discourse capital X mu A of x raised to the power k by x, and here this k is again is the value of k is less than 1. But normally the value of k here is 0.5. So, if we do not mention any value of k, the value of k here is understood as 0.5 for dilation. So, then if we are let us say dilating a fuzzy set A, continuous fuzzy set A, so we can represent the dilation of A as A raised to the power 0.5 within bracket equal to the summation over the universe of discourse capital X mu A of x raised to the power 0.5 by x. This is for the continuous fuzzy set. Similarly, if we have the discrete fuzzy set, then we can use this expression for dilating a fuzzy set A, dilating a discrete fuzzy set A, and this fuzzy set will be A raised to the power 0.5 within the bracket equal to summation over the universe of discourse capital X mu A of x raised to the power 0.5 by x. So, this is for the discrete fuzzy set. The first one is for the discrete fuzzy set, and then second one is first one is for the continuous fuzzy set, and the second one is for the discrete fuzzy set here. So, this way we have understood the formulation remain the same, formulations remain the same for the dilation, same as the concentration except the value of k. So, in concentration the value of k remained always more than 1, whereas for dilation the value of k is always less than 1. Now, let us take an example here to understand the dilation of any discrete fuzzy set. Here in our case it is A. So, A is given to us, and it is defined by the elements here, the 0.1 by 2 plus 0.7 by 3 plus 0.8 by 4 plus 1 by 5, see here. So, this is a discrete fuzzy set within the universe of discourse capital X, that is 1 to 5, and you see now we have to find DIL, means dilation of A. So, we see here that for dilation of any fuzzy set we need the value of k as well, but here since the value of k is not mentioned in this example. So, we will take a value of k as default here 0.5. So, the value of k is automatically coming as 0.5 for dilation, if nothing is mentioned. Similarly, if it was a concentration, it was for concentration, we could have taken k is equal to 2. So, now let us take the dilation of A, let us do the dilation of A. So, we have A as a discrete fuzzy set here, discrete fuzzy set. Now, when we do the dilation, we need to increase the power, we need to raise the power of the respective membership values to 0.5, which is here corresponding its generic variable values. So, when we do that, what we are getting here is this. See, dilation of A is coming out to be 0.316 by 2 plus 0.836 by 3 plus 0.894 by 4 plus 1 by 5. So, we get a new fuzzy set, which is a dilated fuzzy set, which is the outcome of the dilation of a fuzzy set A, and as we know that we have got this by taking the square roots of the respective membership values corresponding to all generic variable values. So, this way we have found the dilation of a fuzzy set, discrete fuzzy set A here, and similarly other fuzzy sets can be taken, and the same on the same lines the dilation of the fuzzy set A can be found out. Now, if we take another example which is on the continuous fuzzy set. So, here we have a continuous fuzzy set. Let us say this fuzzy set is a bright, this fuzzy set is used, this fuzzy set is to represent the linguistic term bright. So, we have this example where we are taking a fuzzy set, continuous fuzzy set here to represent the linguistic term bright. Now, if we are interested in finding the dilation of this fuzzy set, again we have to do the same which we have done in the previous example, but here since we have the continuous fuzzy set, since bright is a continuous fuzzy set, it means the membership function is a continuous fuzzy set to give this continuous fuzzy set. So, in our case, in this example, mu bright of x is a Gaussian membership function which is represented by an exponential function, the Gaussian function e raised to the power minus 1 by 2 into x minus 20 over 5 raised to the power 2. So, this is the continuous membership function, and this continuous membership function is used to represent the continuous fuzzy set. Now, if we are interested in finding the dilation of this fuzzy set, the bright fuzzy set, we can write the dilation of bright, and then in this way this can be written by the bright raised to the power 0.5. So, since we are going for dilation, so we have to have the value of k less than 1, and since the value of k has not been given in this problem as well, so we have to take the standard value of k, that is 0.5 for dilation, and when we do that, we simply raise the power of the membership function by k, and here k is 0.5. So, we simply write here e raised to the power minus 1 by 2 into x minus 20 over 5 raised to the power 2, and then whole raised to the power 0.5 by x. So, this way when we plot this, when we represent this here, so this blue colored fuzzy set basically is for, this is for bright, and then here the green colored fuzzy set is nothing but the dilation of bright. So, we can clearly see here that what is happening here is the original fuzzy set, original continuous fuzzy set, which after taking the dilation of it has wider spread. So, we see that the spread of the fuzzy set is increased. So, dilation of any fuzzy set always increases its spread. So, in this case, in this example, we have a Gaussian membership function for the fuzzy set which is used to represent the linguistic term bright, and when we have dilated the bright linguistic term, so the dilation, the normal dilation is giving us the new fuzzy set which has more spread and is shown by a green color here in this picture. So, this way we have understood the dilation here, and now let us go further to talk about the composite linguistic terms. So, composite linguistic terms can be formed from one or more combinations of primary terms here, logical connectives, and linguistic hedges. So, let us use all of these words, all of these combinations together to get or to build the better linguistic variables, or in other words I would say let us use all of these to modify to get the modified linguistic variables. So, if we can use primary terms, logical connectives and linguistic hedges, so we see that when we use all of these, one of the composite linguistic terms can be like this, like we have not very young and not very old. So, here we have and as the connective, and we see that what is the primary term? Primary term is basically young and very old. So, primary term is this primary term. So, like that when we use all of these together, we can form a new linguistic variable. This is also called a composite linguistic term, and similarly we can have another composite linguistic term which is here as young but not too young. So, obviously here we see that we have but is the another connective which is used for and. So, here but is connective, and then in other case in the third one we have middle aged or old. So, we have are as the connective in this case. Similarly, in the fourth case we have and as the connective. So, this way in all the cases we are getting a new linguistic term, and we would call these as the composite linguistic terms, and this we are getting out of all the primary terms, logical connectives, and in some cases the linguistic hedges. So, let us first understand that how the linguistic edges we can obtain. We have already discussed these linguistic hedges, and these linguistic hedges basically we obtain by either dilating the original fuzzy set or concentrating the fuzzy sets. So, let us take an example here to understand the composite linguistic term out of the primary term and the connectives and hedges. So, let us take this example. So, in this example here we have the linguistic term light and heavy, and of course, these light and heavy are, since these are the linguistic terms, linguistic values. So, these will be defined by some fuzzy set, and here light is defined by this fuzzy set, heavy is defined by this fuzzy set, and these two are the continuous fuzzy sets, and these membership values, membership functions mu light is defined by a bell shaped fuzzy set. Here this mu light is this, and then mu heavy is this. So, this way both the fuzzy sets are continuous fuzzy sets, and both the fuzzy sets are different fuzzy sets. Now, our job is to find the composite fuzzy sets out of the given fuzzy sets as primary terms. So, we see that we can have the composite linguistic terms like this, like we can have light but not too light, and then we can have slightly light, we can have extremely light, we can have heavy but not too heavy, we can have slightly heavy but slightly heavy, and then finally we can have extremely heavy. So, like that all these composite linguistic terms we can manage to get by using the primary terms, primary linguistic terms for light and heavy, and then its hedges and connectives. So, let us go one by one. So, here since the primary terms, primary linguistic terms are defined by or characterized by suitable continuous fuzzy sets, and here we have these fuzzy sets, its membership functions as well functions for light and for heavy as well. So, it means that we have mu light of x is equal to bell of x semicolon 10 to 30, and then we have mu heavy of x is equal to bell of x semicolon 15 3 70. So, this means that we have two well functions which are the membership functions for the light fuzzy set, the fuzzy set for light and the fuzzy set for heavy. So, let us first define the fuzzy set for light. So, fuzzy set for light is this here, you can see, and since the light has its mu x, its membership function, and this membership function is coming from here, this membership function is coming from here. So, the light fuzzy set can be defined by the integration over the universe of discourse capital X, and then 1 over 1 plus x minus 30 over 10 mod raised to the power 4 and then by x. So, we see that we have a bell shaped membership function for light and for heavy both, and we all know that the parameters that are given here for the bell shaped are 10 to 30 in place of A, B, C respectively. So, we have basically A is equal to 10 and B is equal to 2, C is equal to 30 for membership function for light, and similarly the membership function for heavy set, heavy fuzzy set, we have A is equal to 15, B is equal to 3, C is equal to 17, you can see here. And on the same lines we can have a fuzzy set for fuzzy set representation for heavy. So, these both the fuzzy sets light and heavy are different because of its membership functions. So, membership functions are different, the nature of membership function remains the same, both are well shaped membership functions, but their parameters are different. And we can represent these fuzzy sets here. So, here we have the fuzzy set for light, which is represented by blue color, and then we have the fuzzy set for heavy, which is represented by the green color here. So, this way we have two fuzzy sets as the primary terms, or in other words we can say the primary linguistic terms, light and heavy. So, we can say this is as light and this is as the heavy. So, these both the fuzzy sets are there. So, these are already given. So, now we are interested in the composite linguistic term, which is here, which is light but not too light. So, let us try to get light but not too light. I am writing this here, light but not too light. So, please understand that the fuzzy set for light is already there. So, I am writing here light, this is fuzzy set for light. Now, we have to make the composite fuzzy set, means we need to find first the too light. So, when we say too light, it means for getting too light we need to concentrate the fuzzy set light. So, let us concentrate the fuzzy set here. So, when we concentrate the fuzzy set here, this is the fuzzy set for too light, this is fuzzy set for too light. So, the fuzzy set for light is already there, and here what we are doing is we are concentrating the light fuzzy set to get the too light. So, when we concentrate the fuzzy set light, we are getting the fuzzy set as too light, which you can now very easily understand. So, this way we have got the fuzzy set for too light. I can write it like this, the too light. Now, since we have obtained the fuzzy set for too light and we need not too light also, not too light, the fuzzy set for not too light. So, now let us take the complement of too light to get the not too light fuzzy set. So, here we are taking the complement of too light, and this is going to give us the fuzzy set representation for not too light, and this way we are getting here the fuzzy set for not too light. Now, we are interested in light but not too light. So, first we have here the fuzzy set for light, then we have the fuzzy set for too light, and then here we have the fuzzy set for not too light. Now, we have to find a composite fuzzy set which is out of the light but not. We have here a connective but, and but is nothing but and it is equivalent to and. So, we will basically compose these fuzzy set. So, we have a composition of a light fuzzy set here, because we are interested in light but not too light. So, we should take light and then not too light, and then we connect this by but. So, but is, as I already said, it is and. So, let us now find the composite fuzzy set here, the modified fuzzy set here out of light and not too light, and both the fuzzy sets are composed by composed with and connective. So, here when both the fuzzy sets are superimposed on each other. So, the light but not to light is going to give us the intersection of light and not to light. So, this way we are getting this portion when we take the intersection. This I will again mention as not to light, and this is for light, this is for to light. So, this way we have, you see, composite fuzzy set, which is the outcome of light, but not to light. And of course, here this fuzzy set is for not too light, and this fuzzy set is for too light. This fuzzy set is for light. So, this way we have obtained the composite linguistic term, which is represented by the fuzzy set light but not to light, which is here. So, with this I would like to stop here, and in the next lecture we will continue with few more examples on composite linguistic terms. Thank you.